In today's video, we're looking at what happens when 3D printing meets construction, and how a bit of forward thinking can make affordable community living for the homeless a reality. We'll explore the life and creations of legendary architect Michael Jansen, and we'll discover how one Chinese company is creating a rotating, light-up dome home of the future. And finally, we'll get a sneak peek at the company that's developing human habitats for use on the Moon and Mars. I'm Glenn, and let's get to it. Chinese company Zhuzhong Besta Technology was founded back in 2017. Since then, it has been busy researching and developing high-end plastics manufacturing. After securing more than 28 invention patents and publishing more than 30 papers, Zhuzhong Besta Technology are now the market leader in plastic rotomolding and prefab production. Their entry into the compact home market comes as no surprise. Zhuzhong Besta Technology's ability to mass-produce highly specialized plastic products places them at the forefront of this emerging industry. The Galaxy Villa is a prefab dome-shaped smart home with some surprising features. Firstly, the entire home sits on a base that houses an intelligent rotating system. Want sunlight on your face for 12 hours a day? At the touch of a button, the shell of your Galaxy Villa rotates, pointing your windows and doors in whichever direction you want. Suppose you're planning to set this villa up off-grid. In that case, the base cavity contains the housing for the intelligent rotating system and a septic tank and batteries. The exterior also lights up with vibrant LED panels powered by roof-mounted solar panels. The interior is customizable, but the base model includes a generous-sized bedroom and ensuite with large French windows spanning the front of the villa. A panoramic lifting porthole skylight sits on top of the Galaxy Villa, giving owners a chance to stare at the stars before they fall asleep. Do you see the Galaxy Villa as a party weekend house or a sustainable off-grid habitat? Let us know in the comments. When it comes to deciding the perfect shape for strength, both above and below ground, you really can't go past the dome. Its outstanding surface-to-volume efficiency makes it ideal for critical structures. Think biodomes and nuclear power plants. But that's not the only benefit of dome living. The interior of a dome surface can be utilized as an immersive display, taking advantage of the well-documented improvements to digital real estate. For these reasons and more, Massachusetts-based company Immersive Construction chose the dome for the Orbio habitats. Built from fiberglass-reinforced plastic and insulated with polyurethane foam, the Orbio comes prefabricated as a whole or delivered in two 8-foot-wide halves that are joined on site. The Orbio's dome measures 160 square feet of floor space. It can be either freestanding or buried underground for added strength and protection. Once assembled, there are a range of configurations and uses the Orbio can transform into. Everything from micro-habitat to gaming den, flight simulator to a tiny office. The included features make anything possible. The 40-degree 2-projector video wall you now have provides a backdrop for flight simulators, gaming, immersive media viewing, and so much more. Without any flat surfaces to create noisy reverb, the sound is a lot clearer inside the Orbio. Inside, you'll also find a kitchen and galley, a wet bathroom with a shower, ample storage space, and a fold-away sleeping loft in the roof of the dome. If you're still cramped for space, expansion modules can be utilized to lengthen your Orbio to whatever size you like. For over half a century, postmodern artist and architect Michael Jansen has been designing and building projects that he fondly names his M-vironments. With a focus on prefabricated and modular construction, the LA-based architect has produced some of the most visually stunning and sustainable habitats available. Let's look at some of the creations that have made Michael Jansen a verifiable rock star in the industry. The Autonomous Dwelling, 1978. This project was commissioned as a mobile, autonomous dwelling, a curious hybrid between camper and off-grid outpost. Built from the roof of an agricultural grain silo and insulated with cellulose foam, the autonomous dwelling is both weatherproof and efficient. Rainwater is collected and stored in bladders, with solar heating providing warm water to the included amenities. This semi-permanent dwelling is tied down with 4 anchors. Still, it can be easily unhitched and prepared for transport. The Mini House. If your dream home involves living alone, Michael Jansen's Mini House might be the perfect retreat. At just 8 feet wide and 12 feet long, the Mini House is designed to fit on the back of a standard truck for transport. Modular, the Mini House can fold out and exist standalone, or connect to other pods to expand the living space, creating an infinite combination of arrangements. The Homestead House. Building on his work from the autonomous house, Jansen has reimagined his off-grid habitat with the Homestead House concept. Each modular section features the same recyclable steel products and can be assembled in any number of configurations. Continuing with the upgrades, Michael adds in photovoltaic cells and a wind turbine for power generation. The Inside-Outside House. Movable, prefabricated, and modular, the inside-outside house is difficult to get your head around. The white sections of the construction represent the interior of the house. At the same time, an endless array of additional frames and cladding surround it. Environments. The best way to describe environments is like a Lego set without the instruction manual. With a limitless number of uses, configurations, and construction options, Environment is a sustainable and functional work of art. Would you live in a house built by robots? Or do you still think Terminator could be a documentary? Even if the AI singularity terrifies you, the DFAB house in Switzerland is exciting. Found on the roof of Switzerland's ETH Zurich University is the impressive 200-square-foot DFAB house. It's the first house in the world to be designed, planned, and built using primarily digital processes. A mixture of 3D printing, modular construction, and digital rendering was used to build this 3-story house. A digitally generated model of a steel mesh is created in high precision and then filled with concrete using an on-site robot fabricator. This method works for standard building elements and structurally optimized, curved, and non-standard geometries, with minimum waste, less material and energy, and considerably lower production costs. This fabricator can be fitted with different tools, allowing it to work at sites that are dangerous, unhealthy, or too complicated for humans. The DFAB house also includes smart innovations such as wastewater heat harvesting, automated climate control, and more sensors than you'll know what to do with. Welcome to the future. Tucked away in a neighborhood in East Austin, Texas, is North America's first permitted 3D printed home named Chicon House. Commissioned by the Bjarke Ingels Group and utilizing products developed by Icon Robotics, Chicon House is an excellent example of how additive manufacturing and 3D printing will revolutionize the building industry in the coming decades. A specialized robot was developed called the Icon Vulcan II, a heavy-duty robot designed to work in areas with unstable power supply and little access to potable water, perfect for developing countries. Also, brand new building material was created called Lavacrete, which dries faster and is stronger than traditional concrete. The Vulcan II can print an entire home in less than 48 hours with little human assistance, and virtually no waste when set up. With the success of Chicon House, Icon and their partner, Mobile Loaves and Fishes, set their sights on scaling up for humanitarian reasons. The Community First Village is a radical plan to eliminate chronic homelessness in Austin, Texas, with extremely low-cost housing and community organization. The Vulcan II started printing over 130 templated microhomes, outdoor kitchens, laundry and restroom facilities, and other community buildings. But that's just the beginning. The further expansion aims to build more than 500 homes on 51 acres. Proving that 3D printing can also produce high-end and luxury houses, Icon partnered with developer 3 Strands to develop a series of 2 to 4 bedroom dwellings. Over a dozen homes have been completed already. Designs include floor plans with private yards, covered parking, vaulted master bedrooms, large windows, and tailored interior design. The East 17th Street residences represent the first 3D printed homes available for commercial sale in the United States. When you're in the process of building houses that are out of this world, why not design them for another planet altogether? With ambitions to return to the moon and soon venture to Mars for the first time, the next frontier permanently puts humans on these respective celestial bodies. Partnering with Bjarke Ingels Group and Search Plus, Space Exploration Architecture, Icon has created Project Olympus to develop autonomous systems to build habitats on the moon. Building on Earth is one thing. Add in the low-gravity atmosphere, high radiation, absence of oxygen, and 500-degree temperature variations, and you've got a whole new set of challenges to figure out. But the moon isn't the only real estate we need to start building on. The Red Planet is the next frontier, and building permanent habitats for our explorers is also high on the agenda. For that reason, Icon and their partners have been given a home at NASA's Johnson Space Center in Houston, Texas, to build their version of a Mars habitat. Together, they've developed the Mars Dune Alpha, a 3D printed 4-bedroom habitat complete with quarters for 4 astronauts. They also included 2 bathrooms, 2 hydroponics labs, a gym, kitchen, dining, infirmary, and workroom. There's even a robot station for our friendly android assistants. Currently, training astronauts are required to live in the Dune Alpha for long periods. Let's just hope they get used to it. Pretty soon, it will be the only house within a million miles. If you enjoyed this video, you could help us out by hitting the like button, subscribe, and keep up to date on future posts.